Here's another derivative rule. We know this because it says find h prime of 5, and we've been told that h is this chain rule. G is inside of f. So we know h prime of x will be the inner prime times the outer prime with the inner plugged back in. We always have to do that. Or in this case, it's really just the inner is g prime of x times the outer derivative would be f prime of g of x. That's our rule. And so now we go and look through the table. We need g prime of 5 because that's what our rule calls for. So here's g prime and here's 5. So that's a 6. The next thing we need is f prime of g of 5. So first, we need to figure out what g of 5 is. So we look back through our table. Here's 5. Here's g of x. G of 5 is going to be 7. So that is 7, g of 5. Well, I still need f prime of that 7. So I look back in my table. Here's 7. And here's f prime this time. They line up at 4. So this is really 4. So I have 6 times g prime, or f prime of g of 5, or f prime of 7. That was all 4. 6 times 4 is 24. That would be our answer for this problem here. Now let's look at a new one in the same grouping. This time they want f of x plus g of x. That's my h. Well, if we want h prime of 2, since there's no multiplication or addition, we can just say, hey, like, I can find that derivative and add it to that derivative. So what's f prime of 2 plus g prime of 2? Well, I go to my table. F prime of 2 is negative 2. And g prime of 2 is 2. Well, negative 2 plus 2 is 0. And here's yet another example in that same grouping. This time we have two functions multiplied. Well, there's our product rule. That's our p prime q plus our q prime p, or in this case, we could think of it as f prime at 2 times g of 2 plus g prime of 2 times f of 2. So according to our table, f prime of 2 is 8, g of 2 is negative 9, g prime of 2 is this 11, times f of 2, that's negative 1. Now we've got some simplifying to do because they say in simplest form. 8 times 9, that's going to be negative 72. 11 times a negative 1 is negative 11, or negative 83.